Hello everybody, welcome back to another 3D Hangout. I'm Noel Ruiz, designer here at Adafruit, and joining me every week is Mr. Pedrock.
What's going on everybody? Pedro Ruiz, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is a show where we combine 3D printing and DIY electronics to make inspirational projects for you folks, the viewers. Speaking of which, welcome everybody to the chat room. Thank you so much for joining us today. It is Wednesday.
Episode 116. Thank you all again in the chat room for joining in.
That's right. Today's coupon code is MAGLACE, not to be confused with MAGLACE.
MAGLACE will get you 10% off in the Adafruit shop. So if you want to get something before the holidays, I suggest you do it now before everything is completely sold out.
I think it already is. We're working hard at manufacturing, so bear with us, folks. There is some shipping deadlines. You can check out adafruit.com/blog to get, it's a featured post, it's pinned, so you can see the last date to get stuff for whatever's in stock.
We got our usual roundup of freebies for all of our tiers. Depending on how much you spend, $99 gets you a, one
of these pens. It's kind of like a mystery, so you either get Cappy, Mo, or Adabot.
And $150, you will get a 32-4.
Yeah, Adafruit Feather 32-4, basic proto.
And $200, you'll get all of that, bag of chips, and free shipping.
Yeah, I don't know about the bag of chips. We're working hard with that. Okay, we also have same-day delivery to the fine folks in New York City. So if you want something the same day, you can order it and get it the same day.
That's right. If you, or after you put in your zip code, it'll show whether you have that ability.
Okay.
Take advantage of that if you need something shipped the same day.
Righto.
Put in your orders before 11 a.m.
Yeah, 11 a.m. Yeah, ET, Eastern here. Yeah. Okie dokie.
Quick shout out to the chat room. Got our usuals in there. Ryder, Stuff Kirby, Stuart, Benji, J. Brown, AS8 Designs, Alfred, and Fat Pig 2727.
Wow, welcome guys.
Morning everybody.
Good morning. It is the morning here in the Eastern. Charles Crawford the third. Hey, welcome. Thank you for joining us. All right, so this week's project is brought to you by the power of magnets. Where is it? There it is.
I always like working on magnet.
All right.
Magnet projects are always super fun, especially when they're super simple and
very useful.
Very useful. I've been wearing these for about 3 weeks now. We talked about these last week. They are the magnetic shoelaces. Now there are a couple of these already available, like on Amazon, or they were actually a Kickstarter from before, because Phil saw these and was like, hey, we should do a remake of these. Super easy. You have access to all the Fusion 360 files, so you can customize these to build your own, because you pretty much will, it's guaranteed you're going to have to, because everybody's shoe is different. And excellent project for teaching kids about design, 3D printing. Lovely little lesson plan to add to your curriculum. A full guide on learn.adafruit.com if you want to take a look at the files and how to customize these. Yep. I think we're showing it up on the screen right now. Check out the Fusion 360 files if you want to adjust how many magnets you want to put in there. The what are they called? Lacelets? Lace holes? I forget the terminology. Eyelets?
Lacelets? I forget. Wait, you bought these. Let me go back to the thing here. Tell me about the shoelaces. You actually bought these shoelaces because they were a little bit shorter and they have a thin profile, which are really nice.
Yeah, so the original ones that I made for my running shoes here came with these sort of not flat shoelaces, and these were pretty excellent in terms of when you take them off, it maintains the way that they stay upright. The flatter, thicker ones didn't do such a good job, especially because I didn't want to cut the laces off. I just tend to loop them all the way through the center, or the inside of the lacelets here. That only works when you have the sort of loop style lacelet holes for the usual lacelets that, they're just holes actually. I had to update the laces for that. So I just picked these up at Target. They're super thin and they work really well.
Right.
They're not too long, so you don't have to cut them off. You just sort of tie them off at the end there.
If you do have long laces, you manage to kind of thread them through the inside here. So all the excess is right there.
That's actually how I did these here. They're actually just threaded all the way through about 3 times. You can have those in there. Okay. Again, these are excellent for if you have muscle control problems, kids, or if, like me, no matter how many times or how tight you taut these, they always come on loose.
Yeah.
Especially like when you're it's like wet outside or something. It's always like, oh no, now I gotta like tie a wet pair of shoelaces. So if you take a look at the Fusion 360 file,
you want to do that?
Because as you can see, there are different lace holes in there. Super easy to edit. If you go down into the timeline in the lower left-hand corner there, if you just hover, it'll tell you what each step does for adjusting. So if you click on these...
Oh, you named them?
Yeah, all of them are named, so you can take a look at what each step in the timeline. So if you right-click and you go to rename right underneath Edit Feature... I did not
know you can do that.
Yes.
You hit rename right here?
Yep, hit rename, and it pops up right there.
That's pretty awesome. So that gives you a great visual of... what's going on here?
Yeah,
I didn't know you could label, because you can label
like,
stuff here, but you kind of have to dig through your sketches and whatnot.
Yeah, it's the most annoying thing. After you're done editing, you're like, oh no, what was that one
especially
step?
When you have a bunch of steps. But this is nice and cohesive, so very easy to
super simple. You can take a look at all the steps that I took to design it, and you can visually look at building all the patterns for this. So if you wanted to add more magnets, you can stretch it out more, and then over there on the right hand corner, you can type in how many, or actually you can just slide this across, which is a little more fun to see visually, adding more magnets or laces. If you cancel out of that, go into the lace pattern.
Right here.
Yep, you can take a look at that as well. And it's really great for students, especially if you have a limited amount of calipers. You can visually see, is this going to collide with the cavities, or is this going to be big enough?
I just want to see if the preview's coming through, because yeah.
Oh, the speed.
It's all good. Yeah, it's all fine. Okay, cool. So it's very it's customizable in that sense. So I took this opportunity to kind of remake this using user parameters. So I did a tutorial not too long ago about using user parameters, and it's this guy over here. It's under modify, so you can bring this up. So I put together a couple parameters. I can't resize this window. I wish I could, but maybe we can do this right here, so you can see. There you go. So I have magnet diameter, magnet thickness, magnet count, the distance between them, the hole diameter, and the hole distance. So the cool thing about this way to do it is that you can really customize things with just changing a couple expressions. So in this case, let's say we have a different magnet. Let's say it's 6 millimeters of diameter. Hit enter, and it kind of updates to it. Now, there's a little bit of work that you have to do in terms of just making sure that things don't collide. So you can see I got an error here, but you could make it bigger. Let's make it bigger here. You can see how it adjusts. And I could even adjust the thickness of the magnet. Let's say it's a little bit thinner. Let's say it's 2 millimeters thick. You can see that it kind of adapts to it. Now, there's still a lot of stuff that I want to do with it. It's not completely dynamic. You see, I kind of have to mess. Let's say I change the diameter, the distance of the magnets. Right now it's set to 30. Let's increase it to maybe 50. And you can see that the overall length of the shoe closure changes, but I still have to modify the hole distances. So I have to kind of mess with the numbers a little bit, maybe a little bit more. But you can get really granular with it this way. Maybe that's too much.
And the great thing about this, if you have a different diameter magnet, you can quickly adjust that.
Yeah, so it's kind of an interesting way to do it. Also, the hole diameter, you can change that too. So it's up to you guys to kind of take this and see what makes sense to you. But ideally, what I'd like to do is make it so that the hole magnets adapt to the overall width of it. And there's a way to do that. I'm just still kind of learning it. I'm going to go through some more tutorials on Fusion's YouTube. So there's ways to kind of combine these things to say, kind of multiply them, and because if you were to change the count, like the actual magnets, let's say I wanted to have 4 of them, it'll update in the sketch, but the actual extrusion won't update because there's only so many profiles selected. So if I go into the sketch, you can see there's more magnets in there.
Yeah, so you'd have to sort of tie the sketch bounds that create
the
whole
extrusion.
body.
Yeah, the extrusion has to be bound to it at some point. So I'm going to try to learn a little bit more of it, but this should be enough to kind of get a quicker, a really easy way to kind of play with different dimensions. So this is a great project too that can utilize user parameters.
And if anybody makes something inside of the customizer, inside of Thingiverse, definitely link that. We will add that to the guide and credit you as well. But if you just want to visually see the adjustments that you're making, you can check out the first Fusion file for that as well. Yeah, so two different methods of it, but both very useful. They're both customizable. Yeah. Nothing's kind of stop you from modifying it, so there you go. Yep, and you can change the diameter inside of this one as well. You can also change where the lace holes for that one is. I think if you open up version, the 4 holes right there, you can take a look at a little bit of modifications that I did to that one in terms of moving the lace slits around, or the lace holes around, and adding more magnets. So a couple different designs, because everyone's shoe will be different. I think so. The sizes, the style, the color. Yeah, I mean, this is a blocky. This is very blocky, but you could add, kind of fillets here to kind of give them a bit more organic look, I suppose. Exactly. Yeah. If you take a look at some of the ones that are for sale, you do have like this nice little. They sort of move the lace holes out of the way. Have this nice little curves on each one. Another thing to note is that these are actually tolerant fit. They're press fits, so Pedro didn't use any glues, so you can. They have a very sort of. The tolerances aren't going to be the same for every printer or every material, so they're going to change a bit. And you also found that some of the magnets have variations in their diameters, so you might need to change that. You're absolutely. This is one of the projects where it's not going to fit right out of your printer. Like one, you measured one magnet. You should measure all of the magnets. Made a set and then printed out the other set after I was finished testing it, and found that the magnets slipped right off. It's kind of fun. We'll be able to pull each other out of the cavities. Yeah, and you can also multiply things together. So you can like multiply different user parameters. Like you say mag diameter times 1 or mag diameter times mag distance. So that's kind of neat. Nice little tip inside of Fusion. If you wanted to do some calculations inside of the actual like this the input dialog box, you can go in there and do math, like 5 millimeters plus 10 millimeters, so take away 2 millimeters, and it will do the math inside there for you. That's great. So instead of adding numbers, expressions is awesome. All right. If you guys have any questions about it, let us know. And these, again, are fitted for the magnets that we have in the shop. Yes. So this project should cost about $10 to make if you grab those. Of course, you get 10% off as well. Yeah. You could also, there's also other magnets. You can get maybe a bar instead of a circle. Maybe a thinner magnet as well. But these are the ones we carry. And one of the things that also worth noting is that Pedro took it upon himself to kind of constrain himself to what we have available to us. We got a bunch of these magnets, so you might as well work around this and see how can I make it work. Ideally, I was like, Pedro, man, these are too chunky. You should get some other magnets. But he wanted to make it as a challenge. So like, can I do it with what I have? And sometimes that's a great exercise. So good job on that, Pedro. If you go over to the overhead too, you can take a look at the minimal amount of magnets that you're going to require is just 4 of them for each pair of shoes. This worked excellent for these types of shoes, which weigh almost nothing. It's pretty much just like nylon, and the bottom is just the rubber. So these you can bend and jump around and move around as much as you like, and they're not going to come off. These, because they were a little bit more heavier, the tongue was a little bit more thicker, I did require more magnets for this one. So just an extra set of magnets in there. And then one of the coolest things too, when we were looking at, after we finished modeling, designing, making the video, the guide, pushing everything live, we saw one of the promotional videos for one of the companies already making these. they were like, oh, you could just toss these on by your shoe rack. If you have like a metal, you can just sort of tie them on there. And I was like, oh wow, that's so cool. That is, you know, something that I didn't even think to do. So
I hope this
because
goes well.
these are magnets, you can just sort of just toss them on like that.
Oh my God, it works! There you go. They're throwies. They're now throwies. That's
So
pretty cool.
Super cool. If you want to add that to your entryway, like just a little magnet, something to just hang up your shoes. I think that's like the coolest way to do it.
That's pretty
just
cool.
Toss them off after a long day walking around. So super cool, useful project. I've been using these 3 weeks. We walked around. It was like 4 Disney parks in 3 days.
Extensive use, Pedro. Good.
Yeah,
Extensive testing.
I don't know what
Rigorous.
other sort of testing you can do by walking around Disney, chasing down my child. These never came off.
Yeah.
There was one instance though where walking through one of the tracks that move around you when they have the parade at the Magic Kingdom, I did slip down and this did just come off like that and get stuck on one of the tracks.
Right.
But you just pull it off and you're good to go.
That's good. All right.
So that's one of the only, I guess, caveats to having magnets on your shoes is that they're going to attract to any other metal.
One of the other things that come to mind is this could be an opportunity to try to kind of, instead of having to insert them, maybe embed them while it's printing, so it would print and it would encapsulate it. It's very risky, not very risky, but if your tolerances aren't exact, you might crash the head or something like that.
Oh,
and then there's the thing, isn't brass magnetic? So your nozzle will kind of.
Oh.
So maybe that's not such. I just thought of that now. I was like, wait a minute.
Yeah, I've not tested it, but I thought this was an easier way because if you want to, say you scuff these up, you are able to just print more of these
Actually,
out.
brass is not magnetic. I just remembered now. In the Star Trek communicator projects, they're not magnetic, so you might be good. Steel, on the other hand, yeah, you might want to double check. Okay.
So if you ever encounter where something scuffs up, you just don't like the look of it, or you wanted to reuse them, you can take a pair of flush cutters, insert these inside there like that, clip these off, and you can take them out that way.
Right.
Because if your tolerances are tight, they should not be able to come out.
And if you're using adhesives, I highly recommend using E6000. It's a silicone. It's a silicone-based adhesive. It's very industrial strength, but it's still, you can peel it off and it won't leave any residue behind. So I definitely recommend E6000 if you do want to go the glue route, the adhesives. It's a great adhesive. It works really well with 3D prints and other things. I tend to use it a lot with magnets when I need them to stay in place for a while.
In terms of material, I don't think I would suggest using PLA with these, just because if you're out.
These are not PLA.
Yeah, so
What
these
is
are
this?
Using Engine from ColorFab.
Okay.
It's a little bit more
It's a
stronger.
copolyester, I believe.
Yeah. Oh, look at that.
A blend of.
Tolerance was even strong on that one.
You didn't need a heated bed to print them, though, did you?
No, you didn't.
So that's great.
Right.
Good stuff.
So
And
super cool project.
We'll print on just about any bed size, I think, right?
Yeah, you
If
just
you're
gotta
doing the 3.
lower the cooling fan down a little bit. You should be good to go.
Cool.
So PLA, PHA, ABS, something that doesn't have
Yeah,
such
nylon,
low,
something like that.
melting temperature.
Maybe even Ninjaflex would work well.
Ninjaflex
Actually,
would
would
be
be really
the
nice
best, I
because then you can stretch it out and pull them out.
believe. Yeah. So
Good
let's
stuff.
definitely check those out. Hot glue should work.
Hot glue will work, yeah, I think.
Oh, Pupil is saying that he has arthritis in his hand.
That
Hurts
can
to
be
tie your shoes.
that can, yeah.
This is exactly what these
Right.
are made for.
Very
And
practical.
they
So.
cost the exact same as they would if you were able to get them from
Amazon or something, yeah.
with the added bonus of being able to customize these
Right.
and adjust the color, the design.
Tool extrude them or print them,
Extrude,
different
yeah.
colors and stuff. Good stuff.
Art People is asking about, he's a salesman at a large furniture store with 3 floors, lots of stairs. Do you think these would hold up? So yeah, we did a lot of stair climbing. We have stairs in the house here, so I'm always running
and
up the
down.
stairs when
Yeah.
I hear screaming from my child.
No, it's not that
dropped
bad.
this
Come on.
dino and he's making
not
it like
that
it's
bad.
drama. But yeah, of course, all throughout Disney too, there's stairs everywhere.
Mm.
They definitely hold up.
Yeah, they're neodymium magnets. They're pretty strong.
Yeah. So if you see in like we did in the video, the best way to take them off is if you hold on the heel here and then pull your your foot forward.
Yeah.
It's a good way to get them off. But otherwise, no, you can bend these, like I showed in the video, and they don't come off. And it's specifically because of the shoe. If you're wearing something that's a little bit more heavier, you are going to need more magnets for that. And,
or a different type of magnet. Because the way they're touching is they're touching by the sides. So you get more surface if they're like a flat bar. I think you could get some flat bar magnets. We don't carry them, but you can find them all over the place on the internet.
Another way, yeah, you could definitely just wear them like this as well, where where the flat parts are touching, and that'll just give you a more tighter fit and a lot more harder for these to come off.
Yeah, you have to force them out.
Yeah. So a couple different ways you can wear these.
Sorry, let me do the overhead. Wah, wah. There we go.
And I really like in
the video, somehow you're able to stomp it, and they would close.
It's because of the angle of the way that these laces are, so they come off and they just come right back on.
Just stomp and click, like an infomercial.
So before this project, it was always the 3D printed phone case. What I always carried around, when people would
ask, that's a great point.
3D printing, here's one of the designs.
Yeah.
Now my newest one to show off is,
it's always on you.
So
shoes. Great way to showcase the technology and your sort of ability to make design. Cool. All right. That's this week's project. If you haven't checked out the project video, it's on our YouTube channel. And be sure to check out the guide too.
Files for
you link everything up.
Remixing needs.
Remixing needs. Nice.
And don't forget, you can get all the materials, printers, filaments, magnets to make your very own. Cool.
All right. Let's move into future projects. What are we working on? Some future projects that are in the pipeline. You may have seen I'm working on a new project. It's going to be a gamepad that uses Cherry MX switches. So I'm at a pretty good point where I'm going to start making the guide for this. So this is sort of the final project, and it's basically a 3D printed case with 3D printed keycaps, and underneath the keycaps are Cherry MX switches. These are mechanical switches, and I got this idea from watching Colin's Pseudo-Random episode 4 or 3, I believe, is where he talks about mechanical keyboards. And these are mechanical switches. So if you ever hear that sound, it's most likely a Cherry MX switch. So what I'm doing with this project is I designed a custom PCB in EagleCAD, and I milled it on the Othermill. So if you haven't already, you probably saw the video. Let me go to it real quick. Sort of the process of milling out a custom PCB. So here I used the 164-inch flattened mill, which is a nice thin bit. And what I'm using here is a fan bit, which was actually, it comes with the Othermill. And it's actually milled on the Othermill. So you can check out the video. I want to go through the whole thing real quick, but basically just kind of walk through the process of it. And the main goal of this project is to actually show you guys how to mill something out, how to design a PCB in EagleCAD, and then either send that off to a place like Osh Park or manufacture them yourself in-house. Now, a lot of the, not a lot, but there's some comments like, hey, it's very expensive, the PCB, the Othermill. And it is, but it's definitely worth it if you are making a lot of PCBs, or if you're a makerspace or a classroom. I think that's really where it shines. And of course for companies and startups that need to make prototypes right away. Because one of the benefits of being able to mill a thing in literally 7 minutes is that you get it in 7 minutes. You don't have to wait weeks. So if you want more info,
every time that you're working on a PCB design, you send it off to Osh Park. Inevitably,
something is wrong. I forgot a trace, or maybe there's a bridging over here or there. That happened to me. So it happens
as soon as you get your order confirmation. That it's already in production.
It happened to me on the PiGRRL project. Yes.
Yeah. So you're able to quickly test these out. Make sure that all your ground planes are in there.
Yeah. That didn't load. So yeah. this will be probably in 2 weeks per time, because it's going to be kind of like a whole package project where I make a tutorial based on just getting started with EagleCAD, and then the 3D printing, and then sort of the assembly. So I made something before, a couple of years ago. I actually put together a gamepad that uses these sort of regular tactile switches, these really rough feeling tactile switches, and it's a cool project. It uses the Adafruit's Bluefruit Easy Key, which is actually kind of discontinued if you don't know about it. The chip manufacturers really aren't supporting it anymore, and it's not working so well. So this new project is using the Adafruit Bluefruit 32U4, the feather version. So in the tutorial, I'm going to show you guys how you can use the feather component in Eagle, so you can make your own feather wings. Those are sort of Arduino shields, but for the feather form factor. So if I go back over here, I just want to show you guys how it was a lot of wiring involved, and this is really when you want to mill your own PCB. Of course, originally I wanted to free wire it, but you'll see that there's actually a lot of work involved, a lot of wiring involved. So you get this kind of mess of wires, and then you have to kind of fit everything in the enclosure. And the other benefit of using an Adafruit Feather is that it has built-in charging, so you don't need an extra component just to do USB charging for the LiPo battery. So, you know, just a quick look at kind of what it would be a couple of years ago, and then I don't have the guide yet, but it's definitely awesome that there's no wires, and that's the whole point of milling your own PCB, is that, hey, no wires, no traces, right? Okay, so here it is again. It's very small, and the concept is really to make like a gamepad, but with mechanical switches, and Cherry MX switches. And I haven't really seen that done, so I thought it'd be kind of interesting to do that. And I think it's kind of fun. They're very loud and clicky. I mean, you wouldn't play it like this because it's kind of, you'd be more like this. But I like it, man. I think it's kind of cool. So
How slim the actual entire enclosure for this is.
Yeah, it's slim because I don't have to stack things on top of each other. Everything's kind of flat and laid out. So
Then you have this very nice Ninjaflex 3-pin
Yeah.
bumper, so
Yeah.
it does not slide around.
yeah, it stays nice, and it elevates it a little bit. So pretty cool. I like the project, and expect some more content to be released with it. I think later in Thursday, I'm actually going to try to do the EagleCAD tutorial, because that's where you're really going to start off, is like getting the components and then modifying them, because you do kind of have to modify a couple things here and there, but I'll show you guys when the time, on Thursday, most likely. Cool. What else did I have for this?
So
here we go.
So you start talking about
Othermill.
Othermill.
Yeah, so
What
the
does it
Othermill.
look like to actually mill the software?
Sure. So one of the reasons why it's so pricey is because this is fully featured. They really take a lot of the complexity out of milling. So the software is free. Here's what it is. It's called Otherplan, and it has a seamless integration to Eagle. So I'm going to import my board file, and right away it tells you, hey, there's some problems here. I have a little bit of the pitch is a little bit too fine. So I'll change this to 64-inch, and right away it renders it out and shows you how it's going to come out. And this is what you're paying for. The software is really, really easy and straightforward to use. You don't really have to, traditionally with CNC, you have to create a lot of operations to tell exactly what to do. But since Otherplan has a lot of integration with Eagle, it just knows what to do. And it kind of sets everything for you. It has the right clearances and stuff, so you don't have to worry about the thickness of your board, especially if you're using their boards. Yeah, it works really well. So you can do double-sided boards. You can tell it what to mill if you just want to mill out the traces and then use a different bit or something. Yeah, it's really nice. And they have a lot of support, too, on their website. So one of the cool things that I did while designing this is as I would make changes in Eagle, I would refresh right here, this little refreshment, I would refresh the file, and then I would see if I was conflicting anywhere. So you get this nice back and forth of making sure that your end PCB will be milled properly. So yeah, the build volume is about, I think, 4x5. So you can mill a fairly large PCB. And I was kind of, I wanted to add a little bit more buttons, but I didn't want to have to, so Eagle is actually free. It's a free piece of software, but there's a little bit limitation. You're kind of limited to the size of the PCB. So I think it's like 4x5. Like 100 by 80 millimeters or so. So you can check their website out and see. But for most boards, you're going to be able to do it. It's free. It's like Fusion. It's free. So I think it's really nice. So yeah, I need some notes, Pedro. I'm running out of steam here.
Other things.
Okay, Othermill is very. So let's talk about the design of it. So if you go to Amazon, you can actually see that there are some kits available for like $300. Like, hey, I want a CNC for $300. You totally could do that. And there's some assembly required. Okay, maybe here's one. Here's one on Amazon Prime, right? This looks good. One of the things though about it is that it's kind of limiting in terms of you can't mill some certain materials like metals. On the other mill, you can mill metals, you can mill wood, and you have fine-tuned and really fast RPMs, so you can mill something out incredibly fast. With this, you're kind of, you have to do everything yourself to put it together, and you have to kind of find your own software, or write your own software if you need to. So yeah, that's really the main difference is that you get this really fine-tuned portable machine as well. I really like that everything's enclosed, so you don't have dust flying all over the place.
Everything that you're going to be milling is not going to be good for your health. Or you don't want to inhale any of this in. It's
yeah.
Very handy.
But if you want to
enclosed.
do everything yourself, you can totally pick up a kit for $300 or so. It's possible. Hey, I'm throwing out the options out there for you.
Yeah.
So
in terms of figuring out what all the tool bit settings are going to be, they're all going to be included inside of other
yeah, that's right. And there's a lot of things you can do with it. So like I was saying, you can do metals and woods, and you can do 3D milling. So you can do a lot of different projects. There's a lot of settings and stuff here that you can do. But this is for really advanced users when you want to use Fusion 360 to make your G-code. Mm-hmm. And it also has support for Fusion 360. Yeah. You might have seen some of my tutorials on that. So yeah, some good stuff.
And every Monday, or not every Monday, but for a couple of months there, we did have a Milling Monday series.
Yeah.
So if you want to look back at the playlist for that,
there's
a lot of things you can do with it. Like one of the first things we did was etching out some designs on the back of an iPhone case. Yeah, that was kind of risky, but it ended up working well. Yeah, made some dog tags, some luggage tags, and then some really cool ones like CNC engraving on 3D printed parts. Yeah, that was really fun. So you can make logos or typography really right on top of designs and textures on side. There's something that even a 0.25 millimeter nozzle couldn't do. Yeah. You're not gonna be able to do that. You're gonna get like traction issues. You're gonna get all this cleanup. Just CNC milling it out is gonna be the best way to get a very nice, vector look where it looks so crisp and clean on that. And it kind of complements 3D printing a lot. So there's a couple projects where we milled out some elements and combined it with the 3D print. So for example, here we got this iPhone case that has this nice Pokeball. We did a nice enclosure top for the 3D printed enclosure for this Raspberry Pi project, the Pi Lore Pokemon project. So you get some really fun details, and you can kind of see inside the enclosure because you're milling out of acrylic and it's very translucent. So you can do a lot of different things. Pretty cool. Definitely check that out. If you want to take a look at more, and you got a couple more CNC tutorials coming up in the pipeline, so definitely stay tuned for that. Cool. All right. Next up, I think we're going to take a look at this week's Shop Talk. Okay. Boop. So you've been printing some really you want to do the big stuff first? Stuff over the weekend. Okay. You guys remember last week's Time-Lapse Tuesday was what is now a little castle. Yeah. This guy right here. Compared to the new bigness. Yeah, so I designed this in Fusion, of course, and I kind of made it for the Ultimaker Extended. So the Ultimaker Extended can go up to 300 millimeters on the X, right? On the Z. Yeah.
So what I did was I wanted to make a storage bin for Gavin's toys and stuff. So it's completely hollow, so it's only 2 perimeters thick. So it's really thin, but it's still pretty strong. And one of the cool things is that you can print with a very large nozzle. So the Ultimakers come with a nozzle kit, and the biggest nozzle that they have is a 0.8 millimeter nozzle. Typically they're 0.4, so this is definitely thicker. And I even set the layer height to 0.3 millimeters. So I was able to print this relatively fast. So this would probably take literally hundreds of hours. But we were able to print this in 48 hours, which sounds like a lot, but when you combine it to a regular, yeah, that's all the parts. There's just 3 parts. Peter just took it apart. So they're instead of gluing the pieces together, we're using custom threaded coils, or custom threads via coils, which I have a tutorial on if you haven't seen that yet. It's completely hollow. Looks like a bazooka now. But this is probably my biggest print that I made. Again, I designed it for the Ultimaker extended, but this could be printed on something bigger or smaller, I think, if you kind of adjust it.
Yeah, so somebody actually started printing these out on his Printrbot Simple and just combine all the pieces together.
What is up with your arm, man? It looks weird.
You make like some cosplay.
Yeah,
pieces.
so there's a lot. Yeah, I mean, there's a lot of cool things you can do with it, and I think being able to break it down for cosplay projects, it works really well, because sometimes you got to go to a convention, you have to break down your thing and fit it in luggage. So
it's a lot more easier than having like those aligning little nubs that we usually do for sticking pieces back together. It's a lot more easier to just have it twist apart.
Yeah.
Cool. Like you did mention before, you did do a tutorial on how to build the custom coils and threads to build this project together. So
there's a little tolerance, trickery, but overall it worked out really well.
That's super cool.
Yeah. I mean, so it weighs a bit.
It's literally 2 spools.
2 spools, so that's 2 kilograms, about 4 pounds in freedom units. And about 45 hours to print everything. I did run out of filament, and the Ultimakers are nice. They have this pause feature where you can pause it and then change the filament out without having to kind of hot swap, because it is a bowed-in, so it'd be kind of really hard to do that. But they have really nice UX and UI for changing out filament when you run out of it. So yeah.
Real quick in the chat room, Benji is asking what happened to the pattern tutorial for the castle. How to build.
Oh, you want to see that? Okay. Another thing I'd love to show. Yeah, I just haven't had time to do it, but I'm getting more time, and I would love to show you guys how to put this together. This was a little bit tricky to do, because ideally what I thought is, I just make it in flat and then kind of project it over a curve. Not that easy. It really doesn't work that way. You can only project curves, not like flat lines like this. So I'll show you how I built it together. It's basically built with actual solids and then patterns. That's the gist of it. But yeah, I'll show you guys. I will put that together because I think it's definitely worth making the pattern. How do you do that? Okay.
Very cool.
Yeah.
Big castles, and I didn't have the one that we did for this week's Time Lapse Tuesday, but nothing really special. Well, actually, no. The cool special thing about that is all generated inside of the Customizer app. Do we want to jump into that, or?
That's really going out of place.
Okay.
That's for community mix. We'll talk about that. How about Ninjaflex on the Printrbot Simple Metal 2016?
Yeah, so we've been testing the Printrbot Simple out for a couple weeks now, and still, getting our bearings on how the workflow actually is from building all these. This week, Noah, you were testing out different materials inside of it. Yeah, so I needed a little bumper for my gamepad, and I thought that'd be a great opportunity to test out Ninjaflex, because the new Printrbot 2016 model has materials. It has a completely different approach to slicing. Things are done in the cloud, and really what I'm doing here in the video is just showing you that it's working. It's actually working very well. So a part of printing this, I did have to modify the temperature, and that was kind of it, really. So by default, it was set to 230 C,
typically when we do a project with Ninjaflex, we like to print hotter at 240C. And so I changed it to 40C and it printed very well. This thing is printing really, really fast. So I set in the material profiles, you can change retraction, fan cooling, temperatures, and I believe infill, not infill. So what I did was I turned off retraction and I lowered it from 50% speed to 30, but this thing was printing incredibly fast. You saw in the video there, that thing's printing fast. And it had really good layer adhesion. It was really squished. The first layer didn't look too good on the top, but on the bottom it was great. There's no deformations on the or striations on the walls. It came out really nice. The lighting kind of makes it look bumpy, but it's pretty clean. I was very impressed with the retraction as well. There's a little bit of a cut opening there, and there's no string. There was no string on this, and usually you get a lot of string and you have to clean it up. So let me show you guys. So Printrbot.cloud is where you kind of do all of your file maintenance. And right now I have the Printrbot turned off, but in the STL, actually this isn't really what I want to show you, but you do have settings here. But really where the settings were is in the profiles library, the materials library is what they call it. So these are all kind of default other than the Ninjaflex version. So it leads to tell me that yes, Printrbot is tested on a ton of different materials, Ninjaflex, Semiflex, the two of them there. So I did change this, and you can change it yourself here. These are the options that you can change it. They have a type, so they have these set up for you. The brand, you can tell the brand if you're going to have more materials. It's really nice. I don't really see a bunch of other manufacturers doing this. So I did increase this to 240, as I was saying, and I brought the speed from 50 down to 30, and I turned off retraction. Not sure if that's doing much, because like as you were watching in the video, it was really, really fast. Is it going well? No, it's not. Uh-oh. We have missed everything. I didn't have the shot enabled, so sorry about that, folks. Let me see if I can play this back again. So let's take a look at the video again of just printing and kind of recap my experiences with Ninjaflex on the Printrbot. Pretty simple, straightforward. When you load filament, you actually should select the material first and then load your material, because by telling it what material you want to load, you are essentially telling it what temperature to extrude at. So that's very important to do. And another thing to note is when you're how does it know to slice with that temperature? So I think it's kind of dynamic. So your slice is kind of dependent on what material you have selected in your profile. So it printed really fast, and you can see here this is 30% speed, but in
more like 60
this
80.
looks really fast. It is extruding fast.
And one of the things that surprises is that little lip area. There's absolutely no stringing in any of this.
Yeah.
So it did an excellent job.
This is the first try right here. This was excellent.
Yeah.
Of course, the Printrbot 2016 has a geared UBIS hot end, all metal hot end. So I think that assembly really makes it so that it doesn't buckle.
And
yeah.
really tightly grabs onto the filament when it's extruding.
Yeah.
Did a really good job with that.
Yeah. So great stuff. So here's the materials profile. That's a part of the Printrbot Cloud site. So you get your projects, and this tab right here is the materials. So these are all kind of already made for you. I didn't make these. All I did was modify this one here, the Ninjaflex one. So you can edit it. I did edit it. As I was saying, it was at 230. And I just cranked it up to 245, which is a good temperature. And I dropped the speed from 50 to 30 because I was like, yeah, I think 50 might be a little bit too fast. So, but you saw it was really fast. So I don't know if it's doing it. And then retraction is turned off, which I don't know if it's. There's clearly some retraction going on there because there's no string. So I think maybe it is no retraction. I'm not sure. I'm going to do more testing. This is my first try with Ninjaflex. Came out really well. Whoops, let's go over here and just kind of show you the actual print itself. So it's actually right here. This is it. This is the print, my little bumper. So there was no cleanup on this. Do you want to hold it, or? Can't get it straight here.
For this.
Thank you. The first layer was really nice. It was a little bit squished, but you do want to have a nice adhesion to the bed. It's not heated bed, so.
So one of the first things I always look at for
change
telling the quality of the Ninjaflex printed part is looking at the sides here. This is a characteristic of proper flow rate, extrusion, temperature. You can get that shine on there. Usually with parts that just barely work, it's usually like all bumpy on here. It's like matted. This is nice and shiny. There's no
under extrusion.
There's no under extrusion or over extrusion too. So this came out excellent.
Yeah, look at that part right there. There typically I would have to kind of use the Haku flush snips to kind of clean that up, but there was no cleanup on this. I was very surprised. Very, very surprised. Like, what? This worked really well. So there you go. There's our first testing with Ninjaflex on the Printrbot 2016. Really good first test.
Cool. And we're going to keep testing on this. And speaking of printing with the Printrbot Simple, on the blog post tomorrow, they did do a nice write-up of some of the behind-the-scenes that they went into in developing the new, I guess, architecture for the way that their cloud service is doing the slicing with the ESP8266 and the touch screen that they're using on there.
So this is Phillip. He's one of the core programmers that worked with the Printrbot dev team. So he did an incredible write-up here on just all the things that went into using the new Teensy board, using the ESP8266 to handle all the Wi-Fi, the ILI 9341 chipset for the display. It is a capacitive touch, and the micro SD card. A lot of good stuff here. So thank you, Phillip, for sharing this with us, because we didn't see it. ComStack explained. Here's kind of how it's all working together. UART is not enough, Pedro, and data flow is key.
And then there's another video that it's kind of hidden out there.
Yeah, it's actually private. Yeah, it's privately. It's unlisted.
So for the time
and not.
being,
I'll tell you why. I think I know why. And it's not on Printrbot's channel because
they don't want people to use this. Really,
they
this is just
are working on their own Cura. So why would you? This is if.
Okay, let's back up a little bit. So
thank you.
the way that you're slicing is the G code is not compatible with their architecture now. What they're using is CNC code to drive all of the paths and movements on their new printer. So this video here just explains one of the plugins that is available for the current version of Cura if you'd like to sort of, as a band-aid until they finish developing their Cura, to get your custom settings and paths to print on the Printrbot 2016.
Yeah, so here's the plugin, and this is basically a step-by-step tutorial that shows you how to install the software. They're actually using their CrawlBot software to post-process all the slicing stuff through Cura. So there you go. If you have a Printrbot 2016, you're early adopter, and you're wondering how do I get my custom profiles and custom settings through Cura, this is the way to do it. But again, this is, like Pedro says, a band-aid, or just they're working on their own Cura, so you will be able to have very fine-tuned settings.
Yeah, because their slicer in the cloud works pretty good, but on some projects, just because of the nature of the way that it's designed, it is going to need some customization to it.
Yeah.
And they know that, so they are working on that to let you.
Again, this is trying to be really simple. So this is like, hey, here's my resolution, here's my infill, and do I want supports or do I want a brim? And that's really it. You can modify. You can modify it just a little bit, but if you want to have like complete custom,
like if you want to do it like
right, you kind of
a couple of degrees.
Yeah, you can kind of mess with it here.
Like every 45 or 90.
Look at the spinning Adafruit logo. Woo. It's kind of cool. Anyway, I hope that is comprehensive. Okay.
And we'll have these as a blog post for tomorrow. So
That's right.
Check that out.
That's right. Okay. Sorry, I was a little bit all over the place, but hey, next up, just a kind of a quick
update to PiGRRL 2 software by our very own Phillip Burgess.
Yeah, so Phil B put together a new image using the latest RetroPie, the latest version of RetroPie, and now supports the Raspberry Pi 3 without any issues. and it now features the new kind of config files for changing your keyboard and remapping your keys. So it's a little bit more easier. So that's good. So you can check that out if you haven't already. If you have made a PiGRRL build and you want to update your Raspberry the RetroPie software, you can do so now. So check it out.
Super handy.
Yep, it's on the blog right now. Okay. Back to these shots.
And I think we can now jump into this week's Community Makes.
All right, time for Community Makes. This is where we highlight some projects in the Maker community that are made by you folks. So first up, let me pull up. First up is Aiden, XYZ Aiden on YouTube. Check him out. Subscribe if you haven't already. Aiden has been experimenting with large nozzles. That's cool. A 2mm nozzle, not 0.2, but a 2mm nozzle. So he's been playing around with it on his Ultimaker original. And the videos, I have an ad now. Sorry. How dare you, MakerBot? Come in here.
Yeah, some of the people we've actually seen using larger nozzles are, the sort of bigger, like, Delta bots that are always like at Maker.
Yeah, if you go to Maker Faire, yeah, exactly. You got Part Daddy from CB&T. The Wasp printer is really giant.
So they're usually using ginormous nozzle diameters just so they can print huge things like, furniture and things like that to speed up the print because nobody's going to wait around for 40 hours plus. So this is a great way to get very large prints in a minimal amount of time. Yeah, so
check out Aiden's video because he talks more in depth about it. It burns through filament, some things about speed, you got to slow it down a little bit. But yeah, these are really cool experiments. So shout out to Aiden for experimenting with that. It's great stuff.
I think links to the listing that he actually got these for.
Yeah, so these are what you link before you get 5 of them. There's a 1mm, a 1.5, and a 2. So I think you could use this with a 175 filament, and obviously the 2 for 2.85mm filament. These are really thick holes, man. Crazy.
Definitely would have came in handy for printing.
Yeah, I think printing this. Yeah, I have this on order, so it might take a little bit to get here. But yeah.
Real quick, Benji's saying that they used the 1mm nozzle and found the support almost impossible to break off.
Ah, that's a good point.
So one of the settings you could change is the, I forget what they call it in Simplify 3D, but it's the horizontal, just how close the support material actually touches the
air
model.
gap?
Yeah, I think it's the air gap. Okay. So definitely try increasing that. I think the default is 0.3, so maybe.
In what? Like Simplify?
20. In Simplify 3D, okay. Yeah. Under supports.
And if using Cura,
I have no clue how to do Cura.
Sorry, we don't use Cura. No, we like Cura. We use Simplify 3D a lot.
The new version in 2.3.1, if you click on the little cog wheel next to the supports, there is additional settings that you can adjust inside there.
In this computer, I don't even have Cura installed. Sorry, folks. I would show it to you, but
there's a way to do that.
Yeah. Let us know if you know in the comments, so people know. Okay.
The other one was this week's Time-Lapse Tuesday, which is this really cool castle generator.
Again, don't forget to subscribe to Aiden. I'll have his link below, and we'll have it on the blog. Okay, what is it, this thing?
Yeah. So if you go ahead and take a look at the Thingiverse post, this was all made inside of a customizer. Nice little slides to adjust and build your very own customizable castle.
It's pretty dope. So you'll never get, no two castles are the same.
I know. One of the things I wish that they had was the ability to save the settings that you used on that so you can update it from there. Once you generate it, it just gives you an STL model of that, and I don't know what the settings I used to make. Something that sort of resembles the Magic Kingdom's castle, or Cinderella's castle.
Yeah, this is an impressive print. This is printed on blue tape, no curling issue.
No heat.
No heated bed.
Yeah.
There's definitely heat going on in this nozzle.
On the bed, yeah.
Yeah, so what filament did you use? Oh, all the settings are right there. There you go.
This is the purple translucent filament that we have in the shop.
Yeah, it's from Ultimaker. Not Ultimaker, Ultimachine.
Very lovely.
Very low infill as well. I was very surprised.
I like how this didn't even go through half of the spool.
How many hours was this? Like
34 hours.
Yeah.
Feels pretty light, and even at 5 percent infill, it was able to print out all the little top parts of that, where the steps are for the castle. This came out very lovely, so definitely check that out if you want to grab the generated file that we built on this. It should be linked in the blog post as well.
Okay.
Pretty cool. Nice big giant castle.
Big things, yeah. This would definitely benefit as well for a big nozzle. You print it faster.
Yeah, very cool.
Okay. So there you go. Another community make. Augustine doing it again with the low polygon stuff. This time R2D2 and C3PO. Dual extrusion version as well.
Turning into our default file testing for the dual extrusion printers.
Yeah,
so definitely check him out. Give him a tip for all the lovely work that he does. Always coming out with the newest pop culture models, dual extruded versions, and the source files are also included.
Didn't you print it? Let's take a look at it.
Actually, yeah, I did. It's going to be actually next week's Time-Lapse Tuesday. We have an evil version of R2D2 here.
The Sith version.
Sith version. So there's little pins in here that print along with it, so you can adjust this. And it came out really good. So this was printed on the Ultimaker 3 dual extrusion head. I think the white was actually being used up on the BCN Sigma, which is why I printed it in black and gray, but it came out pretty good.
Oh, looks good. Calibration looks good.
Yeah, recalibrated the nozzle, the X and Y and the Z for that. It came out really good. Again,
no supports,
legs,
right?
Yeah,
no,
absolutely
no
supports.
pillar, no waist.
He calls supports, I forget what the quote from him is. He thinks it's using supports is something from the dark side.
That's funny.
So yeah, all these just pop together. The middle wheel just inserts inside there. Did have a little bit of tolerance issues, but nothing that couldn't be solved with just loosening it up. I just used a screwdriver that was a little bit bigger.
I recommend a file, but okay, screwdriver.
The file was a little bit too thin.
You might break a leg if you do that. So, okay.
Definitely a nice test print to make sure that your nozzles your heads are nicely calibrated.
Are you going to do C3PO next?
I think so. Yeah.
With a red arm?
I think the red arm would be pretty awesome.
Oh,
so I'll chop that out.
Okay.
Actually, that's what I thought he was working on when he posted the teaser of it on Instagram. So definitely follow Augustin.
Yeah.
Augustin.
Flowistic
on Instagram, Thingiverse, and send some
Twitter.
tips over his way.
Yeah.
Excellent job on that.
Cool.
Cool.
Yay, Ultimaker's doing it up. All right, that's our community makes. If you folks have any projects you'd like us to share on the show, you can do so by contacting us directly or emailing us directly at support@adafruit.com. We'd love to share it. Yeah. Cool. It's Q&A time.
If you guys have some questions, type them up in the chat room. We are streaming on Facebook and YouTube, so any of those, we'll take a look at that.
Hey, it's Roger. You see that? Welcome to the show. He wants to see it printed on the Sigma. I wonder why.
So I grabbed the new profiles for Cura, and I think he actually even made some for Simplify 3D that doesn't use any of the pillars, so we'll test it out. Yeah. I would have printed it on there, but we were printing this week's...
yeah, I was printing this guy.
All
this was printed on the Sigma, yeah.
And then the week before, we didn't do it on there because we were printing last week's projects on the VCN Sigma as
That's
well.
Funny, yeah. All of my projects have been on the Sigma, so hey, that's my workhorse now. The fun stuff can be done on the Ultimaker. No, it's cool. All right, great opportunity for comparisons. Cool. All right, we're looking. Paige is looking. I don't want to scroll back up.
So, Chalkers is saying that Semiflex works on the MK2.
Yes.
Ninjaflex. Yeah, so that's one of the first things that we almost always test out with new printers. Like, how did they design their extruder? Can it print Ninjaflex? Maybe it's because we're always designing projects that utilize it, but it's one of those things where if it works with Ninjaflex, it's most likely going to work with any other type of material. So definitely a good consideration when a manufacturer is developing an extruder.
Cool. Stort is asking, did we contact Prusa for a new MK2? My printer is on back order. They also have 2 multi-filament attachment options, 2 filament and the 4. That's right. No, we haven't contacted Joseph or anything really. There's a lot of great reviews out there already floating around.
Yeah.
And if the time is right, we'll pick one up and check it out.
Did we see the Z-Morph dual extrusion? No, please post a link to that. You're talking about aliens, right? Z-Morph?
Xenomorph?
Xenomorph? Yeah.
That'd be cool. Wow. Whoa, an i3 steel machine. John built an i3 steel machine looking to invest in an affordable commercial printer. What would you recommend? Well, it depends on what you want to do with it. The Sigma BCN is a great machine at a great cost, great price.
Be stocking those, I think, after the holidays.
Yeah.
For whatever the reason, they've been in the office for a little bit, but with everybody rushing around and getting all the shipments out and posting all the new products, I'll get to those after the holidays.
Yeah, I like the Sigma a lot. It's got a really great UX, touchscreen as well.
Mm-hmm.
Works with Octoprint or works with the standard SD card.
I really like that
Great
it works
stuff.
with
Great calibration settings.
Ninjaflex, dual Ninjaflex.
175. The two, it does
with
just
the
about everything.
Ninjaflex, you have to use 3mm or 285 for the flexible materials.
Hey, that's fine.
Yeah. With
Dual extruding Ninjaflex they worked out really well. I showed last week my Apple Watch band.
Yeah.
Looks really nice.
Let's see. Tucker is saying that he got a clog in his MK2 with the matte filament from Protopasta.
Yeah, I was actually printing out some keycaps with the matte fiber, and it's you really have to kind of fine tune the settings. It's very runny. It oozes a lot, so my tolerances just did not work. It didn't clog my extruder, but yeah, I kind of had to put a pause on it because I really need to get some parts out. But it depends on what you're printing, I guess.
Mm-hmm. Always, yeah. A profile that works perfectly on a simple print is almost never going to work on something that's more complex, that has more retraction or a lot of islands. Mm-hmm. David Fox is asking, what is the fail rate on the Ultimaker 2 Plus? The commercial tells some value over 90%. What's your experience? Huh?
I missed the question, sorry.
What is the fail rate on the Ultimaker 2 Plus? The commercial tells some value over 90%. What's your experience? That's kind of weird that a commercial will tell you that the fail rate is over 90%.
What?
He's asking what.
I know, but
I know that's kind of. Are you sure that's what it said? So the fail rate that we've seen on the Ultimaker 2,
it's pretty low.
It's pretty low, yeah. The success rate's pretty high on it, especially after you've tuned it. We have noticed that the manufacturer for the U.S., who is actually building these Fabric 8 with an 8 for the A, sometimes they weren't built. Like some of the belts were loose, the motors were mounted the wrong way, so it could be that at the way that it was assembled. So just make sure all your belts are tightened. I have had
with ours.
Yeah, with ours, the 2 Plus, the one that's in the garage right now.
Okay.
And
what about the extended?
The extended was built pretty good. I don't think I had to do any major changes on that one.
Okay.
But the regular 2 that Yanni has, and then the 2 Plus did have some assembly.
Maybe it meant success rate, not failure rate.
Oh, okay. Yeah,
that sounds more right.
Yeah. That's what it sounds like, because I don't think a commercial would say, hey, we have 90% fail rate.
Right, unless it's a commercial for someone else's printer. Okay.
Let's see. Other comments. Everybody's just saying that the C3PO files from Flowistic have been updated. If you want to
I saw it in the morning, yeah. Yep.
What 3D printers are in stock and what goes into packing them for the store. So a lot of things that go into it is the photos, all the description for the item.
No, for picking it, reviewing it, like choosing what's a great printer to stock.
Oh, okay. So a lot of the tests are actually on our existing projects. Will they actually work on there?
Right.
Like you were saying before, the first thing that I like testing is, does it work with Ninjaflex? Because a lot of our projects use it.
How about margins, shipping costs, actual logistics?
Logistics.
it's not just us picking them too. When we find a printer that we like, we usually send it to Mary, and she asks for agreements and do they have various certifications and things. And we have like a long contract that the manufacturers have to kind of take a look at and see if they're eligible.
Yeah. But our most important thing is, does it print our projects? How well? How fast?
Is it reliable?
What's the fail rate on it?
Yeah, is the support really well?
Mm-hmm.
So there's a lot of things that go into it, and it's a very lengthy process because our job isn't to kind of stock printers. Our job is kind of to make projects.
Yeah.
The printers are the tools, and hey, it's nice to have a tool in the shop.
Mm-hmm.
So
Exactly, yeah. That's one thing to keep in mind, which is why we don't do so many reviews of like PLA or filaments or printers.
We used to, but it kind of
it's
conflicts with like, hey, I'm trying to do a project. It's going to take me a little bit to.
Yeah. It's really the project that's what we're hired to do. So if it can print the project, perfectly or in a way that
a lot of the times the manufacturers approach us.
Yeah.
So that's a good thing, right? Delta Go, we're still evaluating it. I think we'll put an order in.
Yeah,
the Sigma, it's already happening.
Yep.
Little
nitpicky stuff doesn't work with Octoprint. I like it.
Is it open? Yeah.
Is it open? The filament. Are you able to use any filament that you want? What's the experience like? How's the loading process for filament? Can you pause print midway to change out the filament? What happens when the print fails? How quick are you able to restart from it? How easy is it to level the bed or to adjust the X and Y if it's a dual extrusion printer? Does Simplify 3D work with it, or how easy is it to adjust the profiles for it? And all those little nitpicky
Lots of
things.
stuff.
Yeah.
So it could take a while to get a printer in the shop. Okay.
George is asking if we're still doing our own channel, or is it?
It's just too much.
Yeah,
it's too
way
much,
too
man.
much.
I that's why I have Instagram. I do stories here and there.
That's the only time I actually have time to post anything on there. So if you want to see some of the behind the scenes, check out our Instagrams on that. If we had a project that needed dual extruders, is it doable to convert a single to a dual?
It depends on the assembly, but yeah, I think so.
Yeah,
depends on the printer.
Again, if it's something that conflicts with actually getting the project that we're working on finished, it's not something. That's why we don't really stock any kits or actually look at doing any of the kits because, again, like you said, it's a tool. We need to use it for finishing a project. We don't want the printer to become the project.
Kevin is asking, how do you handle a print that takes over 40 hours or so? Do you print it in stages over multiple days, or do you leave the printer running unattached?
So we do have cameras, and everything's hooked up to Octoprint. So if something does fail, we're able to cancel it. Check the camera and cancel it from there. But yeah, we usually just leave it printing. If you haven't noticed, this is literally in the living room of our house, so it's very easy to hear something that's going wrong or to catch it on the
Just
camera.
check about it as much as you can. If you have a well-tuned printer, then you should be okay.
Pretty good, yeah.
You will need to keep your eye on the filament. That's kind of why we like to have the visual bar here with the filaments in there.
That's the biggest thing. Will the filament last on it?
Yeah, with this one, I actually switched from 175 PLA PHA to 2.85 regular PLA because it just kept running into problems over and over and over again. So you want to have some reliable
on the
filaments. Yeah.
The 175 has been really reliable on the Sigma.
None of these printers have. You could build your own filament detection thing to make sure that you have enough filament. There's quite a few projects out there that you can take a look at. I don't have any. I haven't made one yet, but just kind of keep your eye on it every so often. But yeah, overnight printing can be risky, but when it works, it's great.
Yeah, it's and we do have enough printers to where we're able to sort of parse the work and say, okay, this one's going to just handle this 3-day print without worrying to is it going to take up a queue in a project that we need to print.
Yeah.
Let's see.
All right.
That's going to be it.
Yeah, we are over an hour. Wow. An hour and 13.
Yeah, I think it's time for lunch.
Yeah. Okay. Well, thank you guys so much for joining us today. Don't forget, if you do want to pick up some stuff, support the show, you can do so. Whatever's in stock. MAGLACE.
Yeah.
I think a print just finished.
Yep. I like hearing that sound.
Great. Okay, well, thank you guys again for joining us. Good luck with all your maker endeavors. If you have a project that you'd like to share with us, hey, we have a show and tell that's going to happen tonight at 7:30 Eastern Time. Hope to see you folks there. And after that, we have Ask Engineer with Lamar and Phil. There's the time slot. Back-to-back shows. It's Show Wednesday.
Full packed day today, and then later on throughout the week, you can check it out. Tony D's desk, doing a lot of work inside of MicroPython. Our upcoming new boards are on the way.
I'm looking forward to tonight's new products. New.
And for that, the development of those new products, check out the desk of Lady Ada.
Yep. Follow Adabot on Snapchat. Phil's going crazy with his spectacles.
Oh man, I pulled out my Google Glasses the other day just to feel like I had the spectacles.
Yeah. How's your $1,500 paperweight? No, it still works.
It still records video.
Okay, and it overheats too. All right. Pseudo random. Is it coming?
The latest episode on battery types was posted last.
That wasn't pseudo random. It was Colin's lab.
Oh,
Colin's got 2 shows.
Forgot about that.
We all want more Colin. Please, more Colin.
He's only one man.
Yeah, I know. It's tough, man.
Yeah, everybody always asks, "Oh, why does he take so long?"
Art takes time. You can't rush art.
It does.
It's very artistic. All right, cool. Well, thank you guys again for joining us so much. We will see you next week, right? There's no break or anything like that.
No,
Next week is good.
Yep, next week should be good.
Cool. And look out for my my live stream thing I'm going to do on Thursday. I'll do the texture, and then later I'll do the EagleCAD stuff because I want to show you guys EagleCAD when I'm learning.
Yep.
Okay, that's it from us, guys. We'll see you next week.
Bye.